Welcome back. Segmentation. We have been studying about paging and we saw that paging is a technique that is used for non-contiguous memory allocation. So the segmentation is also another non-contiguous memory allocation technique like paging, but there are some differences. Let us check what are the differences and how segmentation works. Unlike paging, here the logical memory is not divided into fixed size pages. In paging, we saw that logical memory is divided into fixed size partition called pages, and main memory also divided into fixed size partition called frames. And that is how we are allocating the memory. But here in segmentation, the process are divided into several modules called segments, which improve the visualization for users. So, here both secondary and main memory are divided into partitions of unequal sizes. This is a user's view of program. Consider this circle represent a complete program. In a program, there are different modules that we have. For example, we have main function, we have symbol table, we may have stacks for storing some data, we may have some subroutines that is used for performing a certain task, and we may have a square root function for performing some square root operation, and so on. This is the user module. Instead of dividing the program into fixed size pages, divide it into some segments. So, logical address space is collection of segments. The segments are identified by the name and length. The user therefore specifies each address by two quantities, a segment name and offset. Logical address here consists of two tuples, segment number and offset. In paging, we have page table. Like in segment, we have segment table. In segmentation, the user is going to define a two-dimensional address. This mapping is done by using the segmentation table. Each entry in segmentation table has segment base and segment limit. The segment base contains a starting physical address where the segment resides in memory, whereas the segment limit specify the length of the segment. This is an example. Here segment 0, it having a base of 1400 and limit of 1000. Means in main memory, starting of segment 0 is from 1400 and up to 1000 plus 1400 is equal to 2400. Means in memory, starting of segment 0 is from 1400 and 2400. Here we can see an example. We can see segmentation table and we can see physical memory here. Here let us take segment 0. The base is 1400. So in main memory, the segment 0 will start from 1400. We can see in main memory location 1400 segmentation 0 is starting and the limit is 1000, means the length of the segment 1400 plus 1000 is 2400. Also, segment 1 start from 6300 and limit is 400. So, it is between 6300 and 6300 plus 400, that is 6700. Between 6300 to 6700 and so on. Let us see segmentation hardware. This is the CPU which generate logical address. It consists of segment number S and offset D. This segment number will looked up in our segment table. We know that segment table is indexed with the segment numbers. So, segment number will be looked up in the segment table. If we are finding a match, then we will be getting the limit of that particular segment limit is the length of the segment. Now this limit will be compared with the offset. If the offset is more than the limit means it is an invalid access that cannot be allowed. So if offset is less, we will go to S part. We will be adding it with base and we will get physical address. Consider one example. Let us say there is a reference to byte 53 of segment 2. So, where is segment 2? We want to check it in the segmentation table. So, it has a base of 4300 and limit of 400. Now, we want to check byte 53 is valid. The limit of segment 2 is 400 and 53 is less than 400. So, definitely it's a valid one. So, we form the physical address. The base is 4300 and here we add 53, get the physical address.